In the vast expanse of our planet, finding true north has been a challenge that humans have grappled with for millennia. While we've developed various techniques and technologies to aid in navigation, our methods often fall short of pinpoint accuracy. However, nature has endowed certain animals with an incredible ability to navigate using an invisible pattern in the sky, a skill that continues to fascinate scientists and inspire new approaches to navigation. The concept of north is fundamental to navigation, often being the only direction prominently labeled on maps. Yet, for humans, pinpointing true north has never been a straightforward task. Traditional methods like star navigation, while used by cultures worldwide for thousands of years, have significant limitations. For instance, using Polaris, the North Star, as a guide can get you close to the North Pole but not exactly there. Moreover, this technique is only viable on clear nights, rendering it useless during daylight or overcast conditions. The magnetic compass, another staple of human navigation, presents its own set of challenges. It points to the magnetic North Pole, which is currently about 450 kilometers away from the geographic North Pole. This discrepancy, known as magnetic declination, is not static. The position of the magnetic pole is constantly shifting. While we can compensate for this offset, magnetic compasses are susceptible to interference from nearby magnets or iron-bearing rocks, potentially leading travelers astray. Even our most advanced technology, the Global Positioning System, GPS, isn't infallible. Satellites orbiting high above Earth can be affected by solar activity and space weather, occasionally resulting in inaccurate readings. Despite these technological marvels, humans still struggle to consistently and accurately locate true north. In contrast, many animals navigate with remarkable precision, seemingly unfazed by the challenges that confound human navigators. This disparity has long intrigued scientists, leading to fascinating discoveries about how creatures like ants and migratory birds find their way. Early 20th century research into ant navigation yielded surprising results. Initially, scientists hypothesized that certain ant species use the sun's position to orient themselves. However, further investigation revealed a more sophisticated mechanism at play. These ants weren't merely tracking the sun's location in the sky. They were detecting something imperceptible to the human eye: the polarization of sunlight. Light polarization refers to the orientation of light waves as they travel. While humans can technically perceive polarized light, our ability to distinguish between different polarizations is limited. Ants, on the other hand, excel at this task. A 2006 study demonstrated that desert ants preferentially use polarized skylight for navigation, even when other cues like direct sunlight are available. This remarkable ability isn't limited to ants. Migratory songbirds also possess the capacity to detect polarized light, using it to maintain their bearings during long-distance flights. By continuously updating their knowledge of north based on patterns of polarized light stretched across the sky, these birds can navigate vast distances with astonishing accuracy. The phenomenon these animals exploit is known as skylight polarization. It's created by the same process that makes the sky appear blue. As sunlight passes through Earth's atmosphere, it interacts with particles, scattering in various directions. This scattering imparts a specific polarization to the light, creating a global pattern visible to animals with the right sensory capabilities. The polarization pattern in the sky varies depending on the observer's position relative to the sun and the Earth's poles. At the equator, the sun's position changes dramatically over the course of a day, affecting the proportion of vertically and horizontally polarized light near the horizon. As you move closer to either pole, these daily changes become less pronounced. At the geographic poles themselves, a unique situation occurs. The sun doesn't rise and set daily as it does elsewhere on Earth. Instead, it maintains a relatively constant position, causing the polarization pattern to rotate around an invisible point directly overhead. This distinctive feature provides a potential means of locating true north for those who can detect it. While humans can't naturally perceive these polarization patterns, scientists have developed technologies to detect and analyze them. In 2023, a research team published results from a novel approach to finding true north using skylight polarization. Their method, dubbed Skypole, employs a specialized camera and algorithm to determine the direction of true north within a few degrees of accuracy. Although this level of precision might seem modest compared to other navigation techniques, It's important to note that SkyPol relies solely on polarization data. Other methods that achieve higher accuracy often combine polarization information with additional data points. As a new technique, SkyPol has significant potential for refinement and improvement. The researchers behind SkyPol envision their method as a complement to existing navigation systems, particularly in environments like the open ocean where physical landmarks are absent. By harnessing the same natural phenomena that guide ants and birds, we may be able to enhance our navigation capabilities in challenging conditions. The study of animal navigation not only reveals the ingenious ways nature has solved complex problems, but also inspires new technological approaches. As we continue to unravel the mysteries of how creatures like ants and migratory birds find their way, we open up possibilities for more robust, resilient navigation systems that could prove invaluable in various fields, from maritime operations to space exploration. Moreover, this research underscores the importance of biodiversity and the preservation of natural habitats. The navigational abilities of these animals have evolved over millions of years, finely tuned to their environments. By protecting these species and their ecosystems, we not only conserve invaluable biodiversity, but also maintain a living laboratory of navigation techniques that could inform future technological breakthroughs. As we marvel at the precision of animal navigation, it's worth reflecting on our own place in the natural world. Despite our technological advancements, there's still much we can learn from the innate abilities of other species. The humble ant, navigating its way home using invisible patterns in the sky, serves as a reminder of the complex and often hidden processes that govern the natural world. In conclusion, the quest to find true north has led us on a journey from ancient stargazing techniques to cutting-edge polarization cameras. Along the way, we've discovered that some of nature's smallest creatures possess navigational abilities that surpass our own. As we continue to explore and understand these natural phenomena, we open up new possibilities for navigation and orientation, potentially revolutionizing how we find our way in the world. The invisible patterns in the sky, once the secret domain of ants and birds, may soon become a valuable tool in human navigation, bridging the gap between natural instinct and technological innovation.